Day 2 of the biggest AI engineering event of the year had a theme that sounds like science fiction: auto-research. The idea that the machine can now do its own research, run its own experiments, and improve itself. For decades, building AI was something humans did to models. This was the day the field started handing that job to the models themselves. The loop that writes the code, the loop that grades it, the loop that invents the next improvement. All of it starting to close on its own. This is cortical flow. We ran the entire Day 2 main stage through our pipeline. Here is how the people building this field are teaching it to build itself. The frame for the whole day came from an Anthropic engineer named Tarek who works on Claude Code. The models, he said, are grown, not designed. It is closer to a biology than a physics. We give them data and feedback and compute, and then we discover what they can do. His favorite example: ask a normal chat model which Pokémon names end in AW, and it fails even though it knows every Pokémon. But give the model arms, a tool to run code, and it just writes a script, filters the list, and answers. He calls this capability overhang. The intelligence is already in there. The work is discovering how to let it out. And if models are grown, then improving them stops being engineering and starts being experiment. That is auto-research. Tarek's field guide to the new model had a few surprising lessons. First, they removed 80% of the Claude Code system prompt, because smarter models want a smaller one. Give them context, not constraints. Second, most of your work is finding your unknowns, because the map in your head is not the territory of the real codebase. So he has the model interview him, or prototype 4 wildly different designs so he can react. And then he got personal. I loved writing code by hand, he said, but I cannot go back. The only way out is through. His last lesson was the most ambitious. At Anthropic, he said, we believe trade-offs are not real. What if you just did all of it and forced reality to show you the trade-off? Good, fast, cheap. Now you pick 3. Then a keynote from Benoit Schillings, Vice President of Research at Google DeepMind, who has been writing code for 45 years, since the Apple II and the Commodore 64. His title was blunt: code is over, but there is plenty to do. Every era of software, he said, was defined by its bottleneck. First the machine in the age of assembly. Then modular design, where the real limit was the human brain. A typical human holds context between 7 and 9 tokens, he said, while a model's context is basically going to be infinite. And now, the AI frontier, where writing the code is no longer the hard part. When is the last time, he asked, that Gemini wrote a function and I thought I could do better? It is over, because software engineering was never about writing code. It is the day you join a company, find 35 billion lines of PHP, and have to change it. But there is a problem. We ran out of data. 80% of the new code added to GitHub today, he said, is machine-generated, so there is less and less fresh human code to learn from. His answer is the most deep-mind answer possible: self-play. AlphaZero, he reminded everyone, became superhuman at Go and chess with no human knowledge at all, just by playing against itself. Frontier models for code, he said, are now at that stage. They can create their own challenges, judge the answer, even judge the architecture, for hundreds of millions of hours. In a year, he predicted, we will let the model write the code and nobody will look at it, the same way nobody checks their compiler's assembly output anymore. And the real prize he called the gold we cannot see. Humans are evolutionarily biased about what a good solution looks like. A machine with a completely different viewpoint can find the thing that was in front of us the whole time. If the machine is going to do research, how does it actually improve a system? The centerpiece answer came from a researcher named Lakshya Agrawal and a technique called GEPA. Normal reinforcement learning, he pointed out, runs an expensive experiment and then throws almost all of it away, keeping a single score. GEPA instead has a language model read the entire trace, reflect on what worked and what did not, and then rewrite a prompt, because one sentence of natural language can change behavior more than thousands of tiny weight updates. It keeps a pool of every candidate that wins on even one example, so it never gets stuck the way a greedy loop does. The result: One round of reflection on just 3 examples beat what standard reinforcement learning got after 25,000 runs. On a brand new chip with almost no public documentation, where the leading model was failing, it took an agent from 4% to 30%, a 7-fold jump, and the model was optimizing itself, with no expert teacher. And here is the twist that makes it Autoresearch. GEPA does not just optimize prompts. Anything you can write as text and score, it can improve because an agent's entire harness is, in the end, just a Python file. On a hard reasoning benchmark, it evolved a 4-line program into a 6-step agent and took the score from about 32% to 90%. It turned a cheap agent into one that resolved 100% of a set of coding issues in half the time. At Databricks, it tuned an open model to beat Claude Opus while being 90 times cheaper. It even rewrote a cloud scheduling policy to cut costs by 40%. And to the people who assume this matters less as models get smarter, his answer was the opposite. The better a model gets at following instructions, the more a precise specification is worth. Others showed the experiment running itself. One team used a language model purely as a mutation function, reading the current best program and mutating it, while an evaluator scored every candidate on the same 14 discovery tasks and kept the winners. It is literally evolution, with the model as the source of variation. A researcher named Eli showed how you can now reproduce GPT-2, a model that once took weeks to train, in about 90 minutes, and then he wired an agent to that training speedrun, rewarding it only if it beat the record. Then he let it run. It stops every 9 or 10 hours, he said, explores a new direction, and just goes again. And one team demonstrated a full multi-agent, self-improving system that reads research papers and open pull requests, runs its own experiments, and submits a pull request of its own, but only once the findings pass a quality gate. None of this works without a way to know if you are improving, and that is why evaluations were everywhere. Aparna Dinakaran, from the evaluation company AIE, put numbers on it. Her platform runs over 100 million evaluations every month, and the top teams run more than 3,800 different evaluators. Evals, she said, went from the new skill every product manager had to learn to the thing every serious team is now betting on. But as agents started taking long, winding paths with subagents, the old approach broke, because a fixed checklist cannot grade an agent that takes a different route every single time. Which led to her big revelation. What if the best way to evaluate an agent is with another agent? She calls it agent as a judge, adaptive analysis that can follow wherever the agent goes. The day even had a name for its own theme. A speaker named Irina traced it back a few months, to when the researcher Karpathy posted about Autoresearch, and it clicked. Autoresearch, she explained, is simply the experimental loop wrapped around a benchmark. The system proposes a change to a small, tightly controlled part of itself, runs the experiment, and keeps the change only if the score actually improves. That is the whole shape of the day. An automated scientist that reads, forms a hypothesis, runs the test, and keeps what works over and over on its own. And with these self-improving systems climbing benchmark after benchmark, more than one speaker admitted it can start to feel like Autoresearch already outpaces human experts. Why does everything keep coming back to loops? A founder named Ishan gave the sharpest answer. The loop, he said, is the product, and the loop these models were trained around is an old one. It is the OODA loop, coined in the 1970s by the U.S. Air Force to describe how a fighter pilot survives a fast, chaotic dogfight. Observe, orient, decide, act, and then do it again, faster than your opponent. A half-century-old piece of combat doctrine turns out to be the native shape of an AI agent. There is, of course, a bill. The team from Artificial Analysis, who tracked the price and intelligence of every major model, showed the strange shape of it. The price per token keeps falling fast, roughly an order of magnitude for every 10 points of intelligence. And yet the cost per task is going up, because a smarter agent spends far more tokens to finish a job. That matters a lot for Autoresearch, because self-play evolutionary search, and overnight experiment loops are compute-hungry by design. The cheaper each token gets, the more of them the machine's own research is going to burn. So what did day 2 add up to? One sentence. The machine is starting to do its own science. The research loop has moved into 3 places. Into text, where you evolve prompts and harnesses and policies instead of nudging weights. Into self-play, where the model generates and grades its own challenges, the way AlphaZero learned Go with no human knowledge. And into evaluations, the fitness function that tells the loop whether it is actually getting better. Put them together, and you get a system that reads, experiments, and keeps what scores on its own. Everything in this video was built from the complete Day 2 transcript, with every claim attributed to the person who said it on stage. Conference commentary and research opinion, not investment advice. This was cortical flow. See the world before others do.